Okay, welcome back to Mr. Hassan's Maths channel. I'm now answering question number 9 from the International IGCSE Cambridge paper 4, variant 2 of the 0580 syllabus for October-November 2020. This question is about this prism, which has a rectangular base, Abfe, and the cross-section of this prism is a trapezium, ABCD. And AD and BC are the same length. So these two lines are equal in length. So this is basically an isosceles trapezium, this face. It says AB is equal to 8 centimeters, GH is equal to 5 centimeters, which means this is also 5 centimeters because this is a prism. It's the same dimension all the way through from the front to the back. BF is equal to 12 centimeters, and the angle ABC equals 70 degrees. Now, as this is an isosceles trapezium, because these two are equal, in isosceles trapeziums like this, the two base angles are the same, basically. So this angle here is also 70 degrees. Okay, so that's what we can deduce from the fact that AD and BC are the same. They didn't tell us the length of them, but they told us that they're the same. So we can deduce that that's 70 degrees from this, and this is 5 centimeters, is 8 centimeters. Now what we have to do is calculate the total surface area of this prism. Now the prism is made up of basically two trapeziums, which is the front and the back face, and you have 4 rectangles. Okay, so you have a rectangle on the top here, which is 12 by 5. Okay, so you have a rectangle on the top, which is going to be 12 by 5. Okay, and the rectangle at the bottom, which is basically 12 by 8. Okay, that's 12 by 8. And then you have these two rectangles on the sides, okay, which is like 12 by, we don't know what, let's call it x, and this is also x. So we've got two of those triangles, 12 by x. And we've got two of these, two triangles 12 by x, and x is the length of BC and AD, which we are told are the same. So there's two trapeziums, and there's the top and the bottom, and then there's the two sides. That makes up all the surfaces on this shape. So if I find the area of each of these shapes, I have found the surface area of this shape. So let's deal with the trapezium first. Now, to find the area of this trapezium, well, the area of a trapezium is given by, the formula for the area of a trapezium is the vertical height, which is the distance between the parallel sides, which are these, divided by, well, how most people write it is basically a half times A plus B times H. I like to write H over 2 times A plus B. It's the same thing. So it's like a half of the distance between the parallel sides times the sum of the parallel sides. So here we have the two lengths of the parallel sides, but we don't have this vertical height. We need to find what that vertical height is. Okay, that's the distance between the parallel sides. All right, now, one of the things that we should realize is that here we don't have any lengths given to us explicitly. All right, we don't know this length, we don't know that length, and we don't know this length here. However, if this is the vertical height, and this is an isosceles trapezium, then what we can say is that's going to be the same vertical height on that side. And we can also say that basically this length and this length are the same. They must be the same because it's an isosceles trapezium. So those two lengths are the same. And 8 centimeters is basically all the way from here to the end. And we know that between these 2 points is the same as 5 centimeters up there. So these two lengths here, they make up altogether 8 centimeters. That means I have to add up to 3 centimeters. Okay, because you're going to have 5 plus 1.5 plus 1.5. That's going to give you 5 plus 3. So these, because they have to be the same length, and their sum has to be 3, they must be 1.5 centimeters each. So that's 1.5 centimeter, and that's 1.5 centimeter. So now for this trapezium, we can find what we need, which is the area, we can say for this trapezium, we have the distance between the parallel sides, which is, well, we can find what h is now. We know this is 5, and we know this is 8. So to find what h is, we can use the fact that you have this right angle triangle, and we can say from this triangle that the opposite over the adjacent is the tangent. So we can say the tangent of 70 degrees is equal to what we call the height over 1.5. So the height is 1.5 times the tangent of 70 degrees. Okay, now we could leave an answer like this, or we can round it. Let me just show you how to deal with it by rounding first. Okay, so you take your calculator, make sure you're in degree mode. You write 1.5 times tan of 70 degrees, and that gives you an answer 4.121. I'll write it as 4.1212. 1212. Okay, so h equals 4.1212. Now I'm leaving it in this more accurate form because it's not my final answer. Okay, and I want to keep accuracy of my answer. We round our final answer to 3SF. We keep things in between to higher degrees of accuracy than we need in the final answer. One of the things you can do is you can store this answer in this calculator, press store, and then press this button A. So now this is stored as answer A in my calculator. So if I have to use it again, I can just recall it from the calculator. I know exactly where I've stored it. All right, to recall that answer, we go back here. To recall that answer, supposing I want to go back to it later on, I press Shift, recall, and see A is that number there, so I just press A, and that will be the number that I saved in the calculator. So that's now saved in the calculator in its exact form. If I need it again, I can use it. So that's the height of the trapezium. So we can find now its area by using the area formula. So we can say that the area of the trapezium, okay, is going to be the distance between the parallel sides, which is 4.1212 divided by 2 times the sum of the parallel sides, which is 5 plus 8. So that's the area of the trapezium. Okay, now there's 2 trapeziums, so I'm going to multiply this by 2. Why? Because there's 2 trapeziums. So I'll end up just having this number times 13. So I take my last answer. I'll just show you the recall A. Okay, and I multiply that by 13. And that gives me 53.5758. 53.5758. That's the area of both trapeziums. That's both trapeziums, okay? 2 of them. So that's the area of the 2 trapeziums, the front and the back, found. Now we've got to find the area of all these shapes. Now we can find the area of these 2 shapes easily. That's 5 times 6, 5 times 12, which is 60, and 12 times 8, which is 96 centimeters squared. Now what we have also is we have these 2 rectangles here. Now what we don't have is the sloping edge length here, which we can find using the same triangle. Okay, the same triangle here. We can find what x is. We can say that this time we can use the cosine of 70 degrees is equal to the adjacent over the hypotenuse. So it's 1.5 divided by x. So we can say x is equal to 1.5 divided by cosine 70. So we can work out what this sloping edge is by doing 1.5 divided by the cosine of 70 degrees. And that gives us 4.3857. So that's 4.3857. So we have 2 of these rectangles. So if I find the area of the sides, we can say the sides, we have basically 5 times 12, which we already found, is 60, plus, and we've got 8 times 12, which is 96, and then we got plus, and we got 2 times 4.3857 times 12, and that will give us the area of all the sides. So this times 12 times 2, that gives us 105.256 or 257, you can say 105.257 plus 96 plus 60, and that should give us our answer. So we add this answer. Okay, this is the area of the sides, plus 96 plus 60. That gives us 261.257. 261.257. So therefore we got the total surface area is going to be these two added together, which is 53.5758 plus 261.257, and that will give us 314.832. That's 314.832 centimeters squared, which we should round to 3SF unless otherwise stated. It doesn't say anything, so 3SF, that's 315 square centimeters, which is the answer to the question. So that's how you find the surface area of this prism. Okay, so you find the area of the two cross-sectional area of the prism, which is this trapezium, multiplied by 2 to give you the front and back, the area of the base, the area of the top, and the area of the slanted edges. Now, there's a slightly different method you could use to find the area to the area of all these rectangles on the sides. Okay, which is quite an easy way of doing it. It's not really too much different, but basically what it is you'll notice if I put all of these together, this rectangle, and these two rectangles, I would have basically 12 times all of these lengths added together. 12 times all of these lengths added together. Whenever you have a prism, the lateral surface, the surface on the sides, is always going to form a rectangle, even for a cylinder. You see, the surface on the sides forms a rectangle. If you open that up, it becomes like a rectangle. And this length here is basically the circumference of the circle, which is like the perimeter of the cross section. So the perimeter of the cross section is 5 plus 8 plus x plus x. So if we just did 12 times 5 plus 8 plus an x, we found to be what was x again? 4.3857. 4.3857. Okay. Times two of those. All right, that would give you the lateral surface area, because you got this length plus that length plus that length times 12 will give you the area of all those sides. Like you make it into one big rectangle basically. So that's a quick way of, instead of finding the separate rectangles, make it into one big rectangle by finding the perimeter of the cross section multiplied by how deep it goes. Okay, this is like the height of the prism, you could say. So there's the answer to part A. Now we're going to go on to part B. Now part B, it says the perpendicular from G onto EF meets EF at X. Okay, so there's a line which is perpendicular from G to EF. So it's a line that goes from G down to EF and hits at right angles. Okay, so this line here. So the point here is the point X. The point here is the point X. Okay, show that EX is 6.5 centimeters. All right, so EX is 6.5 centimeters. Well, we know that we worked out already, because this is a trapezium which is isosceles. This length is the same as this length. This is 1.5 and this is 1.5. We could say that X to F is equal to 1.5 centimeters and E to F is equal to 8 centimeters. Therefore, we can say E to X is E to F minus XF. Okay, EF minus XF, which is 8 minus 1.5, which gives you 6.5 centimeters. I guess that's what they have to show. It's only worth 1 mark. And we did the work for it already in terms of finding that this length is the same as that length. They're both 1.5 centimeters. Okay, so we worked that already earlier. Okay, then it says calculate AX. Now AX is the length of the line between A up to this point here. We're going to find the length of that line there. Now, if we want to find what AX is, we need some information here. So we know what EX is. So if we consider looking at this from above and looking at the base, if we looked at the base, we would have something that looks like a rectangle. Okay, it would look something like this. Okay, looking at the base of this, you would have E on this corner, you would have F on this corner, you would have A on this corner, and you'd have B on this corner. And then you have the point X, which we just marked. Okay, and we know that EX is 6.5. We also know that this length AE is 12. All right, and we want to find the length AX, which is from here to there. Now, we know that this is a right angle triangle, okay, because this is a rectangular base. We're looking at this from above, right? So this is the length AE, which is from there to there, and this is from E to X, which is from here to here. Now, we want to find AX, we can use Pythagoras Theorem, because it's a right angle triangle. So we can say AX is equal to the square root of, now this is the hypotenuse, so it's going to be the sum of the squares of the two shorter sides. So if I take the square root of 12 squared plus 6.5 squared, that gives me the square root of 745 over 2, root 745 over 2. Of course, we have to give an answer to 3SF, so I press this insert to decimal button, so I get 13.647, 647, sorry. So we can see here that it doesn't tell us how to round it, so we write it as 13.6 centimeters to 3 significant figures. That's the answer to part 2. Then it says, calculate the angle between the diagonal AG and the base ABFE. Okay, so now the angle between a line and a plane. So the angle between AG and the base ABFE. So basically, it's like the angle between this line and, you could say, the shadow of that line as it falls on the base. Okay, you could think of it like that. The angle between the line and the plane is the angle between the line and, you can say, the shadow of that line on that base. Okay, so this line here would be the shadow of that line on the base. Okay, so what we're looking for is the angle between those two. Now, this is not a right angle triangle. We could work out this. We know the length of AG. We know the length of GF. Okay. Yeah, we'd have to basically, we can't, yeah, and the base AG, and the base AB. Okay, so we're going to have to here use something. Let's have a look. Could we use the cosine rule? Do we have to go that far? I don't think so. Let's have a look. What else could we do? The line AG and the base ABCF. Okay. Actually, the angle we're looking for is not that angle. It's the angle, because that's not directly above it. It's that angle we're looking for. Okay. That would be the angle between this is the angle we're looking for. You see, it has to go up to X, not F, because this line, its shadow would not fall down to there. It would fall down to this point, which is X. Okay, so that's something you have to think about here. Right, I drew the wrong thing in the beginning. Why? Because this line, where would the shadow of this line fall? It would fall directly below G. It wouldn't go all the way to F, right? Because G is not above F, so it will fall down to the point X, which makes our question actually a lot easier. Why? Because this is a right angle now, because this is perpendicular to the base. All right, so this angle we can find now is much easier for us to find. This is the angle we're looking for. Okay, this angle here, let me call it angle theta. All right, that's the angle we're looking for. Now we know already that the height of this, we found it earlier in the question. We found the height of the trapezium in the first part of the question, which was the height we found was 1.5 times tan 70, which we already saved in our calculator as 4.1212. If you remember, we saved it in the calculator already. Okay, as if we go back here, we're going to shift, recall, and A. That was the height, 4.1212. So it's really safe. So I know that's 4.1212 over here. This is the height, which is 4 point, whoops, what happened there? Pen changed. Change it back. Okay, so this height is 4.1212. That's the height. Okay, and we can work out what this base is from a to x, which we already actually did. Okay, we found a to x is root 745 over 2, is the exact form. Okay, so this is root 745 over 2. So now we've got this triangle that we can see. If we look at this triangle from kind of this kind of angle, you have a and x and g. So right angle, we know this is 4.1212. We know this is root 745 divided by 2, and this is the angle we have to find. So we can use the tangent. So we say the tangent of theta equals 4.1212 divided by a half of root 745. So therefore, we can say theta is equal to inverse tan of all of that. So I'm going to do this. I'll say inverse tan of, and I'm going to put recall a divided by, I'll have 0.5 times the square root of 745. Okay, and that should give me my angle, which is 16.803, 16.803, which is 16.8 degrees to 1 decimal place, as angle should be given unless otherwise specified. Okay, so that wraps up this question. It's question number 9 from this November 2020 IGCSE Cambridge 0580 paper. Other questions from this particular paper can be found in the playlist that should appear in this area over here. Other questions from the topic of, I guess, it's mensuration and would be over here, and I'll also put it in part of trigonometry, which would be over here. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.